Big orange 2, difference of squares. To do the difference of squares, you need two perfect squares and a subtraction sign. I think we know the numbers that are perfect squares. 25 is one. Do you know another? 16, 49, 9, 1, 4, 64, 100, 10,000, 36. Variable-wise, no, not 2. Variable-wise, any even exponent is a square. H squared is a square, h to the 4th, h to the 6th, h to the 8th. Any even exponent is a perfect square. Because h to the 3rd squared is h to the 6th. So any even exponent, just half of that is its square root. To factor this using the difference of two squares, what we simply do is we take the square root of each one and write it twice with a plus and a minus in the middle. So h squared minus 25 becomes h plus 5, h minus 5. What we're really doing, kids, is we're making a factor tree with a polynomial. We made factor trees with numbers earlier this year, and now we're just doing the same thing with a polynomial. We've just busted that polynomial into two factors. Thanks. Okay? So we're making a factor tree with polynomials. A squared minus b squared would factor into a plus b, a minus b. It doesn't matter whether you write the minus first or the plus first. That's irrelevant, since multiplication follows the commutative property. X squared minus 4 would be x plus 2, x minus 2. Obviously, these get more exciting than the ones I'm giving you now. Right now, I'm just introducing you to the concept. In this case, it does not look like perfect squares. But if we go back to big orange 1, what can we take out of those two terms? We can take out a 3. So the first thing you should do every problem is, can I take something out? And in this case, the answer is yes. I can take out a 3. What I'm left with is y to the 4th minus x squared. Then I have difference of two squares. And the parentheses would then break down to take the square root of a variable to a power, you just take half of the power. So that would break down into y squared plus x, y squared minus x. Okay, you try that one. It factors pretty standardly into difference of two squares into b squared minus 9, b squared plus 9. Then, what you need to notice is that b squared minus 9 also can be broken down using the difference of two squares. So b squared minus 9 can be written b plus 3, b minus 3. B squared plus 9 cannot be broken down because it is not minus. It has to be subtraction, difference of two squares. Okay, so you have to keep going until you cannot keep going. Just like when you make a factor tree, you don't stop when it says 6. You break down the 6 into 3 and 2. When it says b squared minus 9, you break down the b squared minus 9 because you know it breaks down further. Okay? That's the difference of two squares. If you have two squares and a minus in between, you break it down using the square roots and the plus and minus.